Kirkman. All right, we're back again with another lesson from Module 10. We are now finally going to write expressions. We're going to learn how to write expressions. So we know about expressions. You basically know how to write expressions, but we're going to go ahead and practice and kind of recall words that mean different operations and how we can translate English into math and expressions in algebra. So in this lesson, we're going to learn how to write an expression from words or a word problem, and we're going to read an expression or write it in words. So the first thing we have to do is think of all the words that we can possibly think of that might mean different math symbols. So what is a word that would mean addition? What's a word that would mean subtraction, multiplication, division, and what's a word that might mean equals? So pause the video, write down as many words as you can think of for each one. You're thinking, if I'm reading a word problem, how do I know that they want me to add or subtract, multiply, divide, or that something is equal to something else? What are some phrases that people use? And then when you come back, I'll have some words in here for you, okay? All right, here are just some words that mean these operations. Now, these are definitely not all of the words, but they're just some examples. Definitely take a minute though, pause the video and write down as many words as you can, or write down the words that you didn't think of. But what we mean by different ways mathematical operations can be written verbally is like synonyms for addition. So like more than or increased by, the sum, greater than, altogether, a total, or in all. These are words that mean addition. Subtraction is fewer or difference, a loss, decreased by, or less than. Multiplication is a product or times, each, per, twice, right? If they say there were 5 chocolates per student, that means that you'll do 5 times the number of students, or everyone got 2 each, or they were twice the price, that's we would times by 2. And then division, quotient, divided by, split, half, or shared equally. And then for equals is or the same as. And like I said, you may have other words, but for the sake of this being a video, we can't have that discussion. Just write down the ones in here that you maybe didn't have, and we're going to kind of move on from here. We're going to use these words though. Okay. So basically, we are just going to work on translating, okay? It is though we are translating one language to another. We're going to translate English into algebraic expressions. Remember, anytime it says a number, we're talking variable, okay? So the word a number means x or n or a. It can be any variable, but for the sake of this video, we're probably going to keep it to x, okay? And I'm going to kind of show you how I translate each one. All right, so 8 more than a number. So I've got a number 8, and then I have a phrase that means an operation, more than. If you need to, you could go back. More than means addition. So 8 more than a number means I have a number, right? My number is x. I'm going to add 8 to it. 8 more than a number. So my expression is x plus 8, or n plus 8, or b plus 8, whatever letter you want to use. For our video, we're just going to use x. Okay, and that's kind of what you want to do. And if you need to annotate your expression, identify where there's numbers, where there's variables, and then what's the phrase that's telling you the operation, please do it. That is going to help you make notes and make sense of these words. Okay, number 2, the difference between a number and 5. So I have, again, a number. We know that's going to be x. We have 5, and then the difference between. Difference, if you look back on your page, means subtraction. The difference between a number and 5. So I have a number, and I'm going to take away 5. That's the difference between a number and 5. Okay. Let's skip down to number 10. the product of 9 and n. Ooh, if they ever give you the variable, use that variable. If they just say a number, you can use whatever you want. But if they give you the variable, use that variable because it could relate to something specific, like maybe n for narwhals. I don't know, but you want to keep that letter, right? So the product of 9 and n. So product means multiplication. So I'm going to do 9 times n, 9n. Okay. And then I've got down here number 14, the quotient of x and 6. Again, they give me x. So quotient is division. So I'm going to do the quotient of x and 6. So you want to kind of keep it in the same order. So x and 6 divided by 6. Okay, go ahead and do the rest of these. Pause the video and then come back and join me and see if you get the same answers as me. Okay, so some of these are a little tricky. So we did number 3. This one was simple, 19 added to a number, 19 plus x. This one got a little tricky. Whenever you see the word less than, it's actually backwards from what you might think. Because in here we did 19 added to a number. We did the first number first and then the next term second, right? But if I have 6 less than n, I'm not going to do 6 minus n because that's not 6 less than n. That's n less than 6. So let's pretend that n is actually 10. Okay? If I said 6 less than 10, 6 less than 10, that would be 10 take away 6. So do you see how it flip-flops? This phrase less than is flip-flopping. And because subtraction is not commutative, I can't rearrange them and have it equal the same thing. So you want to make sure that you're paying attention to the order with division and subtraction. So 6 less than n is n take away 6. And I kind of drew that little expression. If it was 10, it would be 10 minus 6. 6 less than 10. Okay, the difference of 10 and q, because they were used difference, we're going to keep it in the same order. 19 added to j. K less, we kind of had a typo, it should be k less than 7 would be 7 take away k. 12 less than p is p take away 12 because we want 12 less. So we want to take our number, our original, and get rid of 12. The sum of g and 11, because addition is commutative, I can go either way. I could do g plus 11 or 11 plus g. They mean the same thing. Oh, sorry, g plus 11 or 11 plus g. They mean the same thing. It's only a division and subtraction that you can't do that for. For number 11, we're going to put the 12 in front because that's proper, 12 q's. If you wanted to do q and then a dot and a 12, that would also be proper and fine. Twice a number means 2 times a number. K divided by 10 means k is first and 10 is second. 10 is our divisor. The quotient of x and 6, we've got there, 9 divided by c means 9 first and then c second. Whew, okay, hopefully you guys got those. That's kind of how it is though, but you're just kind of translating, and a lot of these are going to be easy for you. Like I said, subtraction and division are going to be your 2 hardest ones. And then any word that you don't know what operation it means. Like if you still struggle with the word difference, or if you don't know what a quotient is, those are going to be the hardest things. Okay. So in this one, we get to match the card. So we're going to match the phrase with the expression, okay? Find the matching expressions to complete the sentences below. So I'm going to let you do this on your own and then come back and see if you can get your answers. All right, so these were a little trickier than some of the ones we did above, but hopefully you figured them out. So card A matches card G. Because the word and means addition. So twice a number and 5. So 2 times something plus 5. Card B matches I, and that's because we have that less than. So 5 less than twice a number means I'm going to flip-flop them. That twice a number comes first, and then I take away 5. The quotient of twice a number and 5 means I'm dividing, and the only one with division is G. D becomes, this is the distributive property one because it says 2 times the sum of a number and 5. So 2 times whatever the sum is, it would be inside the parentheses. And now this one, I have an error or thing to change. If we go back to the next slide, I guess the less is not a typo, which I have not heard of this before. So you should let me know if you have. But apparently less does not mean you flip-flop it. It actually means that you would keep it the way it is. So if it doesn't say less than, it just says less, then it would be K minus 7. When it says less than, then we're going to flip-flop them. And I've never heard that before. I don't think you're going to see that on a test. But the only reason I know that would be true is because the only thing that's left is H. So 5 less, twice a number. But again, I've never heard it phrased that way. Okay, so there's our cards. So quickly, we have one more thing, same idea. We're going to write the algebraic representation, write the verbal representation, and then say if it's an expression or an equation again. Again, some of these you're going to have to take the expression and do the verbal, and some you'll have to do the verbal and write the expression. But I'm going to pause here. You should too. See what you get, and then join me to see if you get the same answer. Okay, so in these verbal representations, there's lots of different answers. You could go super basic or you could go really complicated. It's up to you. So as long as yours makes sense, then it should be correct. So in this first one, or also I use the green highlighter to show the equations and show the equal signs as well as the verbiage that means the equal signs and why we know it's an equation. So this first one's an equation. I just did a basic 9 times r is 45. Notice that I wrote out my words. I didn't do numbers. That's the verbal representation should be fully verbal. Well, I mean, I guess they didn't do it here, so you could have wrote the 45 there. Okay. 1/3 the sum of 11 and p. So the sum of, and then having there be an expression here that makes like an actual math problem, means I'm going to have those grouping symbols there. So I did 1/3 times 11 plus 3. You could have also done 11 plus p and then divided that by 3 because that would be 1/3 of 11 plus 3. These would be the same. There's lots of ways to do that. But you do need the 11 plus p to be grouped together because it's 1/3 of the sum. It's not just 1/3 of 11, it's 1/3 of 11 plus p, that total. That's expression. The next one is an expression, and I chose to do b less than 5. You could have done 5 less b, I guess. But again, I've never heard that. You could have done 5 take away b or 5 subtracted by b, b subtracted from 5, any of those would work. This next one is an equation. So again, is equal to is how we know it's an equation. And for half, I did an actual half, but you could have done 32 equals g divided by 2. That would be the same thing. Here they gave us a decimal, so 2 times this decimal minus 6. So 2 times 5/10, take away 6. That's an expression. And then the last one is another equation. I chose to use 4 groups of w. You could have done 4 times w. 4 multiplied by w is 18. Okay, and those are our expressions here. Here's a bonus question. It's another one of those 4 students write algebraic expressions and equations. Which students wrote expressions? So you can kind of identify your expressions. I would say, let's see, expressions have no equal sign. So Jeremy did. Oops, there's an is, so not Alejandro. increased by plus d. This is an expression, and this is an expression. None of those other ones have equations. And that's it.